in previous session, you derived this formula for PV type of work. Okay. Then you studied this part. Just want to revise to solve the numericals. Now see here, when pressure is in bar and volume is in dm cube, then work is in dm cube bar. And when pressure is in Pascal and volume is in meter cube, then work is in joule. And suppose if you want to convert dm cube bar to joule, multiplied by 100 and joule to dm cube bar divided by 100. Okay. Now let us see the numericals based on this formula. One more thing you have to remember, when work of expansion, then W is negative, and work of compression, W is positive. Okay. Now consider this. First, read the numerical carefully. Calculate the work done in dm cube bar and joule. That is, find W in dm cube bar, and that is, consider this is as a 1, and second one is required, work is in bar, that is, in a joule. Next, now during expansion of an ideal gas from 4 dm cube to 6 dm cube, now from, that is, this is a, and volume, that is, unit is dm cube, that is, this is a initial volume, that is given here. V1 is equal to 4 dm cube and V2 to 6 dm cube against a constant external pressure of, external pressure is given, it is 2 into 10 raised to 5 Pascal. Okay. Now, whenever pressure is, external pressure is constant, use the formula W is equal to minus P external delta V. That is minus P external V2 minus V1. First write the formula. Now the substitution of values. Before that, you convert that values in a required unit. Now see here, volume in a dm cube. Okay. And we require work in a dm cube bar. Therefore, this pressure must be in a bar. Therefore, it is equal to, that is, or consider like this, P external is equal to 2 bar. Okay. 1 bar is equal to 10 raised to 5 Pascal. You know that one. Now substitute the values. Here, minus P external is a 2 bar, and then V2 6 minus this 4, that is minus 2 into this 2, therefore is equal to minus 4. Now this is a W, unit is dm cube bar. Yes, very simple. I have taken first very simple numerical. Okay. Next, now work in a joule. Second point. Now multiplied by 100. Therefore, minus 4 into 100 is equal to minus 400 joule. You may write in standard form as a minus 4.0 into 10 raised to 2 joule. Both are correct. Okay. Now check that what is asked, that is find. 2 things are here, 2 answers are here. Okay. Check that one. See this one. And one more thing. Here expansion, therefore W negative. Okay. Now let us see the second numerical. Next, second problem. Now it is from the exercise. Okay. 1 mole of an ideal gas is compressed from 500 cm cube. Now here given initial unit gives volume, that is given is V1 is equal to 500 cm cube. Against a constant external pressure, here external pressure given 1.2 into 10 raised to 5 Pascal. Yes, the work involved in this process is 36 Joule. W is equal to 36 Joule. Okay, now calculate the final volume, that is find final volume is equal to question mark. Okay, now external pressure is constant, therefore W is equal to formula minus P external delta V. Now P external V2 minus V1. Now substitute the values. Before substituting the values, convert it into required unit. See here, it is in a Pascal. Okay, it is in a Joule. This is in Joule, this is in a Pascal. Therefore, volume required in meter cube. Therefore, convert this into meter cube, which is equal to 500 into 10 raised to minus 6 meter cube. Yes, therefore, it's equal to 5 into 10 raised to minus 4 meter cube. Okay, now substitute the values. Here W is a compressed, gas is compressed. Therefore, this W is positive. Okay, therefore, plus 36.0 is equal to minus 1.2 into 10 raised to 5 V2. I want to find out, and therefore V2 is a 5 into 10 raised to minus 4. Okay, now first this shifted here, therefore V2 minus 5 into 10 raised to minus 4 is equal to 36 divided by, now this is minus, yes, 1.2 into 10 raised to 5. Now make it 12. 12 3s are 36. Therefore, minus 3 into 10 raised to minus 4. Okay. Now, this is V2 minus 5 into 10 raised to minus 4 is equal to this one. Okay. Now, continue this part here. Here, V2 minus 5 into 10 raised to minus 4 is equal to, see this one, minus 3 into 10 raised to minus 4. Okay. Now, therefore, V2 is equal to minus 3 into 10 raised to minus 4. Now, this here plus 5 into 10 raised to minus 4. Now, 5 minus 3, that is 2. This is common. Therefore, 10 raised to minus 4. Therefore, V2 is equal to 2 into 10 raised to minus 4. Now, what is the unit of V1 here? V1, it is in a meter cube. Therefore, it is also in a meter cube, V2. But see here, you can find out this V2, now another unit, because V1 is given in the numerical in a cm cube. Therefore, you can convert that into cm cube also. 10 raised to minus 4 into 10 raised to 6 cm cube, which is equal to 200 cm cube, this one. Okay, that is a V2. You may find out in a dm cube, meter cube, cm cube. Okay, it's about the answer, volume. Now check that. It is find V2. V2 is determined. Answer with unit. Okay, it's correct. Now let us see next problem. Now next numerical, problem number 3. It is also from the exercise from the book. Okay, calculate the work done during synthesis of ammonia in which volume changes from 8 dm cube, that is from initial volume. This is the unit of volume. Therefore, here given is V1 is equal to 8 dm cube. Okay, then 4 dm cube, that is V2 is equal to 4 dm cube. At constant external pressure of 43 bar, external pressure is given in bar, it is a 43 bar. Now, it is find in what direction the work energy flows. Okay, want to find out this one. Now, constant external pressure means formula is W is equal to minus P external delta V. P2 minus V1. Okay. Now, substitute the value. Before substituting, convert that into required unit. Now see here, volumes in dm cube. Okay. External pressure is in bar. Okay. Now work obtained is in dm cube bar. Now substitute the values. Values external pressure is here 43. Then V2 here 4 minus this V1 8. Now see here what happens. Here V1 is greater than V2. When V1 is greater than V2, gas is compressed. Okay. Therefore, work obtained here should be positive. Here, volume is reduced. That is, V1 is greater. Therefore, gas is compressed. Now, find out this. Here, minus 43 to minus 4. Now, therefore, it is a plus. 4 3s are 2, 4 4 6, 172. The unit for W is dm cube bar, because it is in a dm cube and it is in a bar. Now convert that work into joule also. That is W is equal to plus, now dm cube to bar multiplied by 100. Therefore 17200 joule. You may find out W in kilojoule divided by 1000. It is a kilojoule. Okay. All answers are correct. Now, what is asked? Find in what direction the work energy flows. See here, always remember, if work is positive, then that is gas is compressed and work done on the system. Therefore, you have to mention here work is positive. Work is positive here. The W obtained is a positive. Therefore, work done on the system. Yes, you know this part. Now, work done on the system means work energy flows into the system. Therefore, write the answer. Hence, work energy flows. Work energy flows into system. Already check that what is asked is the answer. And once again, see here. The question asked is this one. Okay. Now, suppose it is same question as a MCQ asked for competitive exam or asked as a MCQ. Then, if within a second you can find out answer. See here, what happened? Volume is reduced, volume is decreased, means compression of gas. Compression, work positive. That is work done on the system, then energy flows into the system. Without calculation, you can, just by observing the value, you can find out the answer. Okay, this is about the numerical number 3. Now let us consider next one, numerical. And then homework. Okay. Now let us see next numerical, problem number 4. Here calculate constant external pressure. That is, find external pressure then required to compress an ideal gas from given is V1 is equal to 23 dm cube to 8 dm cube. That is V2 is 8 dm cube. Next, when work obtained is equal to, it is a gas is compressed, therefore plus 4.545 kilojoule. Gas is compressed, therefore W is positive. Then, now formula. External pressure is constant, therefore formula is W is equal to minus P external delta V. That is minus P external V2 minus V1. Now substitution of values. Before that, first convert that into required unit. Now see here, volumes in dm cube. Okay, then work is in dm cube bar. Therefore, now this much kilojoule, that is equal to 4545 joule, and which is equal to, yes, joule to dm cube bar divided by 100, that is 45.45 dm cube bar. Okay, now substitute the values. So W is positive 45.45 work of comparison, then minus P external, V2 is 8 and V1 is 23. Okay, next, now this one minus P external into 15. It is as it is plus 45.45. See here, sorry, minus. Now this minus plus, therefore here 15 P external is equal to this one plus 45.45. Now external pressure is equal to 45.45 divided by 15. Now which is equal to 10 threes are, then 0.03, that is P external. Now unit is, it is in a dm cube. It is in a dm cube bar, therefore it is in a bar. Can convert it into Pascal, 3.03 into 10 raised to 5 Pascal. That is, you may write this one or this one. Both are correct. Okay. Now, this is about the external pressure required. Now, see here, once check that the find is P external, it is determined. Okay. It's about the numerical. Now, this is the homework, in that 2 numericals are there. You have to solve that. Numericals are very simple. Okay. Then there is a one multiple choice question. You have to solve this. I will give you the answer of this question in the next session. Okay. Next one. In today's session, I have taken 4 numericals. Out of that, numerical number 2 and 3 from the exercise of our textbook. Okay. Now, next session, we will start in the next session concept of maximum work. Very interesting part.